Hello there, it's Jay here from Jay's Vintage Junk, and today it's time to tackle the clock. This is the third and final item that was sent to me by one of my subscribers to see if I could repair. Now, if you remember on the first video when we had a look at all the stuff, this has got a couple of issues. One is that it's not displaying the time correctly. The other one is it's got a power issue. I'll just quickly demonstrate. Plug my USB in here. I'm going to plug it into the side of the clock. The clock will power up, but this connection is so flaky. You see, as soon as I touch it, it loses connection all the time. We can't really start diagnosing what's wrong with the rest of the clock until we can sort that issue out there. So if I hold it, it's alright, but all it needs is just a gentle touch and it knocks it all off again. So the first thing I think we better do is see what we can do about sorting that out. Before I do that, the first thing I'm going to do is take these Nixie tubes out, because Nixie tubes are getting quite expensive now to get replacements, put it that way, and these have actually been modified. These have got a little custom PCB. Unfortunately, by the look of it, they've actually soldered it to the original pins of the Nixie tube. These are Russian 1983. Yeah, these are a Russian Nixie tube. We've got a backwards end there, H-4. But underneath we've got 0883, which I'm pretty sure is going to be the manufacture date. But we will, before we go any further, we will very gently take these Nixie tubes out and just put them out of harm's way. Now, I have worked on a couple of kit Nixie clocks in the past, but this seems to be something a little bit more of a finished product. Right. We've got Allen keys to get inside it. So let's get this top cover off, and then we can actually see what we're going to be up against. Well, it would be the one size smaller than that. And it's one size bigger than that. You're just going to have to bear with me a second, folks, while I find something I can actually get inside this thing with. So back in a sec. Okay, well, I found a security Torx bit that actually fits these Allens, and they're not actually that tight. I mean, I've not even got the screwdriver bit on the end of that, and I can just spin them out, so that'll be fine for getting those out. One there. Another one there. Then we can put this polished top piece out of harm's way while we work on the actual clock proper. Okay, one more. And there we go. That up. So there's very, very, very little to that. Wow. I'll put the top cover out of harm's way there. And as I said, there seems to be very, very, very little to this. Our problematic connector looks like it's on the bottom, so we're actually going to have to take this whole board out of the chassis. There's very little to this. I'm guessing all the interesting electronics is going to be on the back side then. There's something interesting gone happened around that spot there. I don't know if something's been spilt through the top of the clock at some point, or whether that's some heat damage. There's definitely something around there that needs looking at. So before we do any of that though, I want to see what we can do about that USB connector, because it's so flaky it's making and diagnosing any other faults difficult. We've got to remove the board now. Yeah, and there's all the fun stuff. In fact, now a lot of this, I don't know if we can make this out, but there's a lot of, this is flux. They really didn't clean the board off when they built these things. There's a lot of flux residue on that board. That is the offending connector right there. And they appear, let me see if I can get you zoomed in to see this, but it seems that they've actually resorted to hot glue. It's held down, yeah, it's held down with hot glue. Not, well, barely held down with hot glue. But we're going to have to replace that connector there. That's a given. Like I said, that should give us a nice stable power input to it. We've got a voltage reg there. I don't think that's going to be a problem. That is a, I can't actually tell. I'm guessing it's a voltage reg. Oh no, it's not. It's a switching transistor. It's like a MOSFET or something like that, which I'm guessing is going to be being used with these inductors there, and that probably that capacitor, that diode. So we're going to need quite a high voltage to drive those Nixies, and we've only got 5 volts coming into the whole board from the USB. So I'm guessing that inductor there, probably that capacitor and that diode, that MOSFET there, that big capacitor there, because what's that rated at? That's a 400 volt 10 UF capacitor there. So that is what's going to be creating the high voltage for the Nixies. We've got a crystal there. We've got 2 crystals actually. I'm guessing one of them crystals will be driving the to be do with the actual microcontroller there, which is actually basically the brains of the clock. The other smaller crystal there, I think, is actually a clock timing crystal, as though like you'd find on an old PC motherboard, or in like a digital wristwatch or something like that. We've got a CR2032 backup battery there. I'll make sure that that's still alright. It actually looks like this thing may be hand assembled. Looking at the soldering on all the surface mount components, I'm wondering if these things are actually hand assembled. But we've got definite discoloration around that IC there, which is, to be honest, that's going to the clock crystal, so I don't think that's really what's going to be at fault. Right, well the first thing I'm going to have to do, like I said, is change that USB connector there, because it's absolutely mangled and it's not making decent contact anymore. So we'll get the hot air out, we'll get that off the board, and we'll look at putting a new one in. So back in a sec. Right, okay, it's actually been a few days since I started this. I got waylaid with some other things, but anyway, I've got a new power connector there. So I think the first thing we need to do is replace that bad little micro USB connector. I've got a replacement for it there, and I actually think that this has been hand soldered. I'll probably actually use hot air. I'm certainly going to use hot air to remove the old one anyway. So we'll get the hot air in. I'll have to be reasonably careful because we've got you know, other rather small components around there. You're not really going to be able to see this, but unfortunately I'm going to have to kind of concentrate on this more than on the filming, because I don't want to cause any undue damage anywhere. There we go, that's off. That was a dead simple one to take off. In fact, that come off really easy. And that's pretty mangled, it's pretty mashed, that. I've got the new one here. In fact, what I'm going to have to do is just clean up the pads there before we can put the new connector on. And I have left my solder wick and all them bits in the other room, so if you just bear with me, I'll be back in a sec. Right, okay, I found my solder braid here. I've just put a little bit of flux on the connector there. I'll clean my iron off, and we're just going to clean up them pads before we put the new connector on. There we go, a bit more on there. There we go, that's better, because they were a little on the dirty side, those pads. Now I am going to try and do this without using my my microscope. It should just be about big enough to be able to do without actually using my microscope. I've got two options for putting this new let's make sure that is the new one. Yeah, that's the that's the old one. This is the new one. Yeah, because you can see where it's all bent on the bottom there. And I've also just noticed that this is identical to the replacement. There is identical. Sorry, you can't see what I'm showing you. Oops, there we go. Right, come on, focus on them. There we go. The replacement there is identical to actually the one we've taken off there. The thing that I have just noticed though is the board was really actually designed for a slightly different type. Let me get you over onto the board again. The board here is actually designed for one with solder points at each side there, obviously, and then the anchor there, as where these actually soldered from two little points. They've obviously got away with it. They've got away with it doing it that way, but I think I probably will have to. If I'm going to need some light in a different direction, or else I'm not going to be able to see that. You're just going to have to bear with me, folks, because I'm going to have to set some lighting up so I can actually see a bit better from that side. So back in a sec. Sorry about that. I hit record and it didn't obviously start recording. Anyway, all you've missed me do is literally just use a little bit of hot air round there and just slide that new connector into place. What I haven't done is connect the connections on the actual back of it yet. I'm just going to add a little bit of this flux. Just a tiny amount like that. And we're just going to go in with the soldering iron. Get the end nice and clean, and a tiny little bit of solder on it, and we'll just see if we can drag solder. Though this tip on this iron might be a tiny little bit big for this. I might have to just go away and find one of my smaller tips, but let's give it a go. If we put too much on, we can easily get it back off again. Just go in. Just drag solder those in place. Okay, there we go. Right, now I'll have a little clean up around there. I'll get my little toothbrush out and some isopropyl. We'll clean off that flux residue and we'll just make sure we've got some good connections. We might have to just nip in there again and perhaps just reflow, but that actually doesn't look too bad from an initial look. So I'll give it a quick clean up and then we'll go in and have a proper look at it. So back in a sec. Right, we're back. Unfortunately, I lost a little bit of footage. It teaches me to keep overusing the same SD card again because it corrupted itself. Anyway, basically what happened was that's the connector oh no, that's the scrap one. I don't know what I've done with the actual connector. I've just taken off from here. But basically you've seen I got it all on there nice and neat. And unfortunately when I tested we had a short between +5 and ground. And I took it off and I cleaned it up and I put it back on again and I took it off again because I still had it. And anyway, in the end what I've done, I've found a different type of connector. This basically I think what really they should have used in the first place. If you look at the little tabs on the end of that, let me zoom you in so you can see. Oops. No, that's the wrong way. Come on, down you go. Right, it does go in quite far this, doesn't it? That's pretty good. Right, now where are we? Where are you? There you are. Now hopefully we can get it to focus on that. I'll stick my finger there, see if it'll focus on my finger. Come on. Come on. Something else, let's try that. Anyway, you get the idea. If I show you that there, can you see how it's got some little tabs actually sticking out on either side? Which that's the original that we took off. There. You notice how it doesn't have those little tabs at either side. But if we actually have a look at the board, now this is going to be fun. Let me see if we can do this. We'll move that and we'll slide the board into place so you can see properly. Hopefully this will focus, but if you can see where the actual pad is that we've cleaned up there, you notice we've got them 4 little pads there. Now what they've done with the original and what I tried doing was basically sliding that in with the hot air to get it actually lined up in place, and it was held down with some solder in each of them points. And I think what's happened is when I got that solder in there, it's crept under and shorted that out. With this connector, it'll take a little bit of faffing to actually get it all lined up and everything. But if you notice, it's actually got proper tabs which come over here and to secure it in place. I think this is what would have originally been designed to go on this board when this board was drawn up. So I wonder if they'd run out of this type of connector and they were just making do because that's what they had. Because that looks, that looks a lot better there in there. Now, with the amount of struggling I've just done, I don't think I can actually show you me soldering this in place, because literally I'll have to get some magnification on it. Like I said, I struggle like buggery with that one, not using any magnification. Like I said, I did get it on there, but I think that was the issue why it wasn't working. So I'm going to stick this one on there, and then we'll come back and we'll get on with the rest of the repair. So back very shortly. Right, we're back, and that is finally fitted. I'm happy with it this time. I'm just having a quick clean up of the flux residue. Basically what I did is I did end up hand soldering it. I got the finest tip that I've got for this soldering iron, which is a nice little needle tip like that. Got it in position, holding it in position with my finger basically like that, and once I got it lined up where all the pins on the back were lined up, I just tacked it basically on one corner with the soldering iron, and then once that was set and I was absolutely happy it hadn't moved, I basically just went round it then with the soldering iron, soldered all 4 points there, and once that was actually in, I could go in at the back and just touch in the 4 connectors. I mean, I'm not the best person to actually show doing that kind of work. In fact, if you want to see that kind of work, where are we now? Gadget UK is pretty good at it, and a chap that I've been watching quite a bit recently called the Coder. He does not vintage stuff. He does like PlayStation 4s and that kind, PlayStation 5s and all that kind of thing. But watching him do like surface mount work, he's leaps and bounds above what I can do. Lewis Rossman, anyone like that. If you really want to learn how to do surface mount soldering, I said it's not one of my expertise. That's why I'm not a big fan of like showing me doing it, because there's so many other people out there which are so much better at it than I am. But anyway, that I am pleased with that. It's nice and neat, the soldering. That is not going to come off. We've got 4 really good anchor points there. In fact, I think that's probably better fixed than the original one there, like I say, because that I don't think was originally really designed for this kind of mounting. It doesn't have them 4 little tabs that this one had, and the board definitely had them 4 little points for solder. So right, we've got that replaced. I don't think that's going to be the end of this. I don't think that's actually going to fix this quite that easily. What I will do though, I'll just quickly clean the rest of this board, because I've got a fair bit of flux residue on here, basically just from I was using it's a gel flux like this, a syringe fed gel flux, and it does leave. It's not a no clean flux that one. You do have to actually clean up after yourself. It's not a terrible flux actually. It's damn sight cheaper than like the quick chip stuff and stuff like that, but it does the job. It's not a terrible flux. But you do have to clean up after it. That's the only thing. And to be fair, the person, whoever assembled this board originally, didn't do the best job of cleaning up after themselves in the first place. There's a lot of old flux residue on this board from when it was actually made. Anyway, what I'll do is I'll get all the Nixie tubes back out, and we'll get this Nixie tubes back in this thing, and actually see what it's doing now. Have to pull that battery out as well, and find a replacement for that. So I'll go and get the Nixie tubes, and we'll see what it's doing. Back in a sec. Right, okay, I've got it connected up. I've just put one Nixie in for now, just to see what happens. So let's connect it up to power. There we go. Right, so that's powering up. Are we going to get any display out of it? Or are we going to have to just put some more? Wait, come on, powered. Oh, there we go. I suppose what I better do is put the rest of the tubes in here and see where I can actually set the clock, and then see what it's doing. But the good thing is that connection seems fairly fairly stable. Because as soon as you touch that before, it was going off. There we go. We've actually got a display on there. I don't know if you can see that with the light. Let me switch that light out because I don't need it on now. Right, that might make life a little bit easier. But we were actually showing I don't know if you can see that on camera. We're showing a 0 on the digits there. Right, I'll shut that off. The reason I'm actually disconnecting it from over there rather than just unplugging that like that is we actually have some quite high voltages being generated on this board. I mean, not to a lethal extent. You're not going to fry yourself, but you're certainly going to know about it if you get hold of them. Right, that's one. Just a pity that they've modified these Nixies in the way they have and put these bases on them. And the fact is that they've actually, unfortunately, like I said, they've made a little board and soldered the Nixie's pins to this board. So you've got like this adapter to allow it to plug onto this board. Which does mean the problem, if you ever any of these Nixies fail, you have the task of having to desolder all those pins and stick that base onto the new Nixie. Right, let's stick that in there. Last one in, and let's see what these do now. So I'm going to have to be a little bit careful having it all connected up like this, but we'll get over here and we'll switch back on. Well, that's looking... I suppose what I better... Right. Well, that's still got that. I suppose what I better do is get the... but this, that seems... that... What I will do is I will get the manual out and I will see about setting it, but that still doesn't look right there. Like I said, we've got this part of the Nixie with a glow there, which I don't think is correct, but I'm sure we had it doing it twice before. There were 2 tubes doing that. I really I'll get the manual out and then I can figure out actually how I set this, so we can see if we can set the so we can actually figure out how we actually set the clock. So back in a sec. Right, well, I set the clock up. I actually had the display working correctly and it's run for a couple of minutes and it was alright. It was actually showing the time that I'd set and it was timing up fine, and then all of a sudden this has happened. So we have definitely seemed to have a fault on the actual main board of this clock. I'm going to have to do a little bit more research to actually see what's causing this. I have a feeling it's probably something to do with how the segments are actually being driven. I mean, I'm wondering if it's one of the transistors, one of the little surface mount transistors on the board, which is actually misbehaving. It's shorting out as it warms up. Because it's interesting, if I disconnect the power and let it cool down, it'll run for a little bit, and then all of a sudden it'll start doing this, where the segments aren't showing correctly. In fact, I wonder if I can show that now. I'll just switch you off. I'll let it cool down a bit and we'll switch it on. Right, I'm back. I've just having a go at resetting it. There's something definitely very wrong with the electronics on this clock. I've just pulled the battery out, which I thought was flat, and that battery's absolutely fine. It's showing 3 volts. I'm just going through the setup procedure with the clock here again, and I'm up to the stage where you set between a 12 and a 24-hour clock. Now they should be showing at the moment 24 on there. There's definitely still something wrong. Let's try and just get back to where I was, but then like I said, I've got to be super careful with this thing. In fact, I'm wondering whether we've actually got a break inside the board. This is a multi-layer PCB, unfortunately, and like I said, I've redone that connection. That connection there is now fine, but as you move the board, it does still mess up every now and again and shut off. So I'm wondering if perhaps have a break inside the board. Now like I said, this is how we set between a 12-hour clock and a 24-hour clock. Now that's looking okay there. This should just be flashing 12 like that. If I press to advance it onto 24, and these switches aren't brilliant either. There we go. Can you see how that's right? But the 4 has just basically flickered out and disappeared. And then you see that if we move it slightly, and it's not. I don't think it's the actual power connector there, because I've checked all the soldering on that, and that's absolutely fine. It's more as I have to be really careful. Like I said, this board is live, and there's 100 volts or so on this board. It can give you a bit of a tingle. There's no current there, so it's not actually harmful to me, but even so, it's a nasty tingle if you get hit by it. What's if I move the board? I can't get it to do it now. But before, when I was basically moving the board around, it was still losing connection, and I was there we go. Get back to this. So I'll switch that to. So we've lost the 4 completely. If I just touch, it does come back. There. So we've definitely got. In fact, that is weird. It's almost capacitive, this. The 2 is working fine, that's what it should do, but if I bring my hand, look, just touching it brings it back. I bring my hand away, it's gone again. If I touch it, it brings it back. I let go. It's stayed there. It's gone again. I'm wondering whether we actually have some other problems with this board. In fact, what I'm going to do, I'll get some magnification out, and I'm going to go back over this board and see what I can actually find. But I'm wondering whether this is the issue. Now, where it shows like this, I think that should be showing a 0. So we can select that up. 3, 5, 6, 7, 8, 9. Then when we hit 0, it's showing it's showing round like that. So, and now that seems to be working again now, because that's the one that we keep losing before, and that's working again now. we can 29, 28. I think we're on the dates here now. Yeah, we are. So why is it showing it like that instead of an actual 0? That's what I want to. So that's the date set. This should be setting the actual time. So let's call that 23. 8, 9, 10. And that should be seconds set. There we go. I mean that should be 23:10 and 1, 2. So that currently is working. I mean, I know I've not set it to the right time, but at the moment that appears to be actually doing as it should be. So we've got 23:11 and then there's the seconds counting up. I want to know why it's doing that for the 1, unless that literally is how it shows a 0 using these Nixies. I'm not familiar with these exact Nixies. All I know is they're a Russian Nixie tube. But that at the moment seems to be behaving. What I'll do is I'll let it run like this for a while. So I'll pause the camera. I'll leaving this running for an hour or two and see what actually happens. But at the moment, that actually seems to be working okay. But we've obviously got some kind of loose connection, maybe. Anyway, like I said, we'll be back in a bit, and we'll see how it's running. Okay, it's now the following day, and I've basically had the clock on all night, and it hasn't failed. It hasn't actually gone off or anything. I think we've pretty much fixed the connection there. If you look, I can move this around now and flex that about. The clock's not going off at all. Before, when I moved it around, basically the clock was cutting out. Look, I've got to be a little bit careful with this thing. I've actually pulled the data sheet up for the Nixie tubes here. And these tubes run at around about 200 volts. Well, the power supply it generates is about 200 volts. The tubes run between 170 and 160. There's virtually no current there, but it would still give me quite a nasty little tingle if I did something wrong and I got hold of the wrong part of this circuit. What this then leaves us with, so basically we've fixed the micro USB. I'm happy with that now. What this leaves us with now is this issue with the segments, and it's basically 0 which is causing an issue. All the other segments seem to be working absolutely fine. And it's every tube this. When it shows a 0, if you can, I don't know how well this is actually coming out on the camera. I don't know how well you can actually see these tubes, whether they're coming out or not on the actual camera. In fact, I won't know that till I look at this on the computer when I've finished. But if you spot that there, then you see how that is not looking right on that tube. Now watch this tube here, 'cause this is counting the seconds when it gets up to 0. But it's in some weird I've got it set into some weird sequence at the moment now. But look here where it should be showing zeros. It's not showing the zeros correctly. I'll get this just disconnected and we'll have a quick look at the. I'll just, in fact, I can just unplug it, can't I? There, at least that's safe now. I'm not going to get a belt off it. Hopefully you can make this out. I think you can. But essentially, this is the Nixie tubes that are being used. As I mentioned before, they're Russian, and that basically translates to a. I think it's. I can't remember where I've put it now. I think it's a 1N4 is what they're referred to in our numerals. It's a strange thing, H4 in in Russian. But yeah, basically what we've got here is it shows us how the tube's actually connected up. Now there's two ways it looks like you can connect this. So there's it says in the tube with 2 plates or in the tube with 1 plate. So I presume you can either connect just one of the plates up, or you can connect both of them up. Now they'll be the anode plates, won't they? I think that's how these Nixie tubes work. That you put do you put power onto the anode and ground the cathode? It's a while since I've messed with Nixies, I've got to say. So trying to get back around how actual Nixie tubes works is it will take me a minute. But what we're interested in is I think pin number 8 here, which is our figure 0, because that's what basically isn't working. What I think I'm going to try and do, what I think's happening is that when it's trying to counter 0, it's probably got the anode voltage, but I think however it switches to actually form the 0's not working, and that's why it's just showing that glow when it comes to a 0. So what I'm going to do is I'm going to basically figure out the pinouts on these tubes. Valves. Well, I don't know if you call them a valve, because I've always known these as Nixie tubes, but I mean tubes that is like the American designation, isn't it? But basically what they've done, like I say, is they've taken the tube and they've adapted them with these little PCBs on the bottom to 4 plugs like that. So what we'll have to do is we'll have to figure out, I mean all the soldering looks okay there. What we'll do is we'll have to figure out is pin number 8, so what pin number 8 is on there, figure out which pin it is there so we can find out which pin's coming off the board, and we'll actually measure and see what's happening on the board when that drops down to there. So I'll get everything set up, I'll get my meter out and everything, and we'll have a bit of a probe round and see if we can figure out what on earth's going on. Back in a sec. Okay, this is very, very strange. I've just basically got set up to test this thing, just probe around and check some voltage. I've figured out which pin actually on the clock there is the pin that corresponds to the 0. So I've basically connected it up, powered it all up with that one Nixie tube removed, and look, it's all the other tubes are actually working. It's showing 0's. So I really can't understand this. Let us just try popping this one. I don't know if this is a good idea or not. There we go. Right, and as soon as we put that tube back in, there we go, it's not working again. Try pulling that back out. And they're back to working again. Now, does that indicate we've got a bad tube there, a bad Nixie? Because the rest of that seems to be, like I said, now I've pulled that out, those numbers are all looking pretty good, to be honest. No, well, they're looking right. That 0 there, certainly, look, I don't know if you can, whether that's picking up on camera, but that's a decent 0 there now. And then if I put the Nixie back in, look, as soon as I put it back in, I'll pull it out. So what is causing that? That is most odd. Now I wonder if I swap, is it something to do with that socket there, or is it something to do with that Nixie there? Now let's try pulling that Nixie out and let's try putting it in that position. Now they're all working right. Now here's the Nixie that I think suspect. Let's put that in. Look. Yeah. Take that Nixie out and it works again. Let's just try swapping that Nixie there and put it in at the end here. This is where most of the counting's done. Look, it's perfect. Now we can put that back in and look, it's failed again. So it looks like, I'll pull that back out again, it goes back again. So it looks like, unfortunately, we've got a bad Nixie tube there. That is basically what's causing the problem. That Nixie tube's probably got an internal short in it. As soon as you pull that out, it doesn't matter where we put it actually in there, it causes that issue. As soon as we pull that out of the circuit, the rest of the digits are absolutely fine. So basically I'm going to say that the clock itself is fixed. We've put a nice new micro USB on there, so that's not going to be an issue again. So what I'm going to have to do is I can put it all back together. What the chap did ask me about was whether I could make it, add him a switch or something so we could actually shut the Nixies off. Now the only way I think I could think about possibly doing it is finding a way of disabling the high voltage circuit, so it basically shuts the high voltage off to the tubes and leaves the rest of the clock actually running. What I don't want to do, well, what I can't really do is really interrupt the power coming in through that micro USB, because I wasn't expecting this to be all surface mount like it is here. There is no way I can basically break into the traces to add a little switch or something just to shut the power off the whole thing. This is a multi-layer board. I can't, like I said, I can't just, and the two power traces, they don't come out like this. The first thing they do is go through two vias onto internal planes on the board. So unfortunately that's something I did say to the chap I'd have a look at seeing if I could fit him a little switch or something. I do actually have a nice little switch we could use. But looking at the way it's actually wired up there and the way that micro USB and the pain in the backside that was to solder, no, I don't think it's going to be viable to do. What might be possible, what I will do is I'll have a chat with the chap. I'll let him watch this video and see what he says anyway. But what I might be able to do is figure out how the high voltage is generated, and I'm thinking it goes through that diode there, and we might be able to do something where we either kill the power to that MOSFET and shut that MOSFET down, which should kill the high voltage. Or if that diode there is what's used for the rectification for the high voltage, you might just be able to lift that diode out. I'll see which is probably, it might be better just to kill the power to the MOSFET actually, stop it switching, which would just kill all the high voltage side of it, but it would leave the rest of the clock actually running, so it would just carry on telling the time till you flick the switch back up and then it would come back on. That's what we can probably do possibly with that. This is going to be a different matter. Now I will have a look online and see if I can get hold of one of these easily. I have found a source for these in the US. I think they're about $9 each, so they're not mega expensive for anything. The problem is then you've got the shipping and everything on top of that from the US, and it doesn't come with that base on it. It's the standard tube as it would be used, you know, in equipment. So what I would have to do is I'd have to desolder that base from there and transfer the base over. So I will have to have a word with, like I said, the chap that this belongs to see whether he wants to actually go that far. What I will do for now is I will just pause the video and I'll stick this thing back together and we can have a quick look at it rebuilt. So back in a sec. Right, there we go. There's the clock all put back together. Now I'll connect the power up so you can see it run. Oops, wrong way around. Nope, that was the right way around. There we go. Now hopefully, as we can see, it should do its little thing, and there's the numbers. If we look, that is all working as it should do. Like I said, unfortunately, as soon as we plug this one in, it messes up. So we've definitely got a faulty Nixie tube there. What we could possibly do, just for the moment, is we'll take that one out from there. We'll stick it in. If I can get it to, there we go. So the clock would actually work like this. You know, it will show the correct time. The only problem is you're missing the last of the seconds. So I'm going to leave the video here for now. Like I said, we have fixed the main problem, which was the dodgy micro USB there. That is now absolutely fine, and we actually know why the display was acting up, and unfortunately it is that Duff Nixie tube there. So I will speak to the owner of this clock and see how he wants to proceed. Like I said, it won't be the end of the world. We'll have to look at getting a replacement for that. And I said it might be that he knows where you can actually get these modules which have been modified like this with this little PCB on. If not, I'll have a look on eBay now actually and see if I can get these in the UK. I have a couple of Nixies lying around, but I know for a fact I haven't got any exactly like this. I will have a quick look on eBay, see if there's any in the UK and how much I can get one for, and have a word with the chap. And all being well, we'll be doing a part 2 on this where we will sort that Nixie tube out, and we will have a look at seeing whether we can add a little switch here, which, like I say, I'm not going to be able to make something that just kills the whole clock. I don't want to have to mess about too much with that PCB. But what I can possibly do, like I said, is do something that just takes the high tension off the tubes, so basically they don't conduct. The clock would still be running in the background, and you just flick that and the tubes would start displaying again. That is a possibility. Anyway, I'm going to leave it there for now. Like I say, I know you probably wanted a conclusion to this and see it all up and working, but unfortunately it doesn't always pan out like that. And like I said, at least, like I said, we fixed the main problem with the clock, which was that dodgy micro USB. We've got an idea what we could do to possibly kill the display when they want it switching off, and we have found the actual problem that was causing the issue with the numbers. So I'm going to leave it there for now. I hope you enjoyed this little video. So thanks for watching and goodbye.